Okay, kiddos, now let's continue on with our DCP review. Now we're going to talk about Unit 8. So we're going to start with, remember we talked about similar polygons. So similar means same shape, different size. So it's like different size versions, right? And so we talked about if they are similar, then they are proportional, right? So proportional means that we can set up fractions to express their relationships, right? So the angles have to be the same or congruent, and the sides are proportional. So the scale factor, and that's what we're going to practice first. The scale factor is the number that you multiply by to enlarge or reduce. So here's how we calculate the scale factor. It's the new value over the old value. Okay, new value over the old. So we know if we multiply by a number larger than 1, the result's just going to get bigger. Multiply by a number less than 1, which is a fraction, right? The result's going to get smaller. So similar means proportional, and the scale factor is the new value over the original value. Okay, so when we want to calculate ratios, okay, say for instance right over here, right? If they want us to find this length, right? They said find the measure of HI. If these are similar, that means they are proportional. So we would say, okay, X is over here. X would line up with 6. So if X is on the top on this one, then 6 would be over here. And then if we put 21.6 on the bottom, then 8 would go over here. Then we would just cross multiply and divide. Okay, so that's the relationship on those. Okay, so let's go ahead and get right into some practice. All right, so let's check this out. All right, so this one says find the scale factor. Okay, so see if you can do this one first on your own. Okay, so scale factor we know is K, which is the scale factor, is equal to the new over the old. Okay, so the new length over the old length. Okay, so if we're trying to find the scale factor of this right over here, okay, we can compare any of those two sides. So this is the new one, right? Because this tells us which way it's going. So this is the old, right? And this is the new. Okay, so we need to recognize which one's the new. So let's find the K value. So the K value is the new over the old, right? So that means the new value, say, of 30, right, over the old value of what? 13, 6, or 10. Well, of course, it would be the 10. Right? So that means that reduces into 3 over 1 or just 3. Okay, so the scale factor on this one is just calculated by new value over the old value. Okay? All right, let's keep it moving. Okay, that's a level 1 question, right? So that's one of the basic questions. Now, use the scale factor to find the missing side. So, scale factor or proportions, right? We talked about using proportions. So if we're going to use those proportions, it's like we put one fraction equals another fraction, okay? So we want to find the missing side. So let's look. We want to find x, right? Well, what do we know about x? It says, well, what do we know about this? They both share that, and they both share that, right? So if they have two angles that are the same, then they are similar. They're similar because two angles are the same. Okay, so if they are similar, that means we can set up a set of proportions. So we know we need to have, let's say, this one on this side and this one over here, right? We know we need to use x, so let's go ahead and use x. I'm going to put x there. So what corresponds with x over here? Is it 8, 15, or 17? Okay, well, let's look. This one, x is, we have the double and we have the right angle on the side. So double and the right angle. So this one's a double and the right angle would be 15, right? So that would match up with 15. Okay, so then what would I put over here? Since this is the right one, I'm going to put over here. Should I use 8 or 15? 8 or 17? Well, whatever we can match up over here, right? So I know that this is goes between the 1 and the 2. This goes between the 1 and the 2. So let me match those up, right? So I'm going to put 17 over there and 25.5 over there, right? Because those go through those same points. Okay, so now that I have that, I just cross multiply, right? So we're just going to say that times that, right? So that's going to be 17x equals 25.5 times that 15. Okay, so that's going to get equal 382.5, right? And then we know our last step is just to divide by that. So x is going to be equal to 22.5. Okay, so that's all we have to do. If they are similar, is just use those proportions. Okay, so now let's step it up. That was a level 2 question. Okay, that's where most of them are. Now let's go to level 3. So this is applying scale factors for perimeter and area. Okay, so we remember perimeter means add all the sides. Okay, and area is inside a shape. Okay, so let's read this. And these are stuff that we haven't, you may not use, of course, in everyday talk, but I know you can catch on. It says, you are building a roof on a garage such that the gable of the house is similar to the gable of the garage as shown on the diagram. Okay, so I know that you don't use gable all the time, but let's take a look. This is house gable and garage gable, right? So we can imagine it's this. They say it's on top of the roof, right? Imagine that's on a roof top right there, right? So that would be, these are two similar sizes, right? Okay, so the same shape, just different size. So they're saying they are similar, right? They're telling us right there they're similar. Okay, so then it says the area of the gable on the house is 3,024. Okay, so we can say inside this one, right? The large one for the house is 3,024. Find the area of the gable on the garage. Okay, so here's what we need to remember. They want us to find the area of this smaller one, right? So we can imagine, for one thing, we know the value is going to be less than 3024, right, if it's this small. So how much smaller is it? Okay, so the first step is we need to find the scale factor. Okay, so we said that was the new over the old, right? So if we see this right here, that's 14 on this one, right? And on this one, it's 42, right? So which number would go on top? The 14 or 42? Okay, well, we start with this and we're going to this, right? So that would be the new one. So we'd say 14 on top and 42 on the bottom. If we put that into our calculator, that's going to come out to 1/3. Okay, so that's going to be our scale factor is 1/3. Okay, now that we know the scale factor, here's what we need to remember. Okay, to find the new area, okay, we are going to take the that's going to be equal to the original area times the factor squared. Okay, so that's the critical thing, is that the factor is squared. Okay, so to find the new area, okay, so we said the new area, so the gable garage area is going to be equal to the original area, which we said was 3024, right? Times the square of the factor. All right, what's the factor? We said the factor was 1/3, right? So this is our second step, is that right over there? So 1/3. Okay, so what we're going to do is we're just going to put this into our calculator just like that. Okay, so if we put all that into Desmos, okay, that's going to give us the answer of 336 square feet. And we know it's square because we're talking about area. Okay, so that's a level 3 question. That's the toughest one, but here's what we got to remember. To find the new area, we're going to take the original area times the square of the factor. Okay, so 3024 times the square of 1/3 gave us 336. Okay. All right, let's keep it moving. Next, we talked about on proving triangle similar. So we talked about if they look the same, that doesn't necessarily mean that they are the same shape, different size, right? So we said there's 3 different ways. So we need to remember these. AA, right, which means we know at least 2 angles are the same. And in fact, we know if 2 are the same, then the third has to be the same as well. So if we know 2 angles, they're the same on each one, right? We see the same arcs. Or we know that all 3 sides are proportional, right? And so if they're proportional, that means we're going to set up ratios, right? So the short to the short has to be equal to the same ratio of medium to medium and large to large, right? Then the last one we said is side angle side. So side angle side is when we know a side, when we have the same angle, first off. So the same angle in between, and we know the side leading up to the angle, and then the side after. So the side leading up and the side after. And we're going to see the proportion of those. So they have to be the same proportion for it to be similar. Okay, so those are the only ways that we can prove it. They may look the same, but that's how we can prove it, is by either SAS, SSS, or AA. Okay, so if we looked right, let's go ahead and look at our next page for our problems. All right, so it says use your prior knowledge to identify similar triangles. All right, well, what do we know? Okay, well, if you remember, if we talked about first of the year or a long time ago, we talked about if we have parallel lines, right? So these right here tell us these lines are parallel. If we have parallel lines cut by a transversal like that, right? Remember, if it's cut by a transversal, that means this angle right here is going to be equal to this angle right here. Okay, and then if that's true, then that means this angle right here is equal to that angle right there. Okay, so then if we know that this angle is the same as this, so we have two triangles here, right? This one and this one. So if we have, I'm just going to color those separately, right? So we know that's one triangle, right? And then that's a different triangle. So they both share the double, right? And they both share the single. Okay, so that means they're similar by AA. All right, so next it says identify and apply the similarity theorem. So what do we know? This is a side, 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 side. So this one might be side, side, side. It can only be side, side, side if all sides are proportional. All right, so let's look. Let's identify. If this is the shortest side on this one, right? Which one's the shortest over here? Okay, that would be the shortest, right? What would be the medium? If we put that into our calculator, that's actually 2.5, right? So this is actually the same thing as 2.5. So that would be, this one would be the medium, right? That would be the medium, and that would be the longest, and that would be the longest. All right, so we need to see if they're all proportional. So let's check this short over the short. All right, so short over the short would be 1 over, I'm sorry, it's, yeah, so we can do 1 over 2.5, 1 over 2.5, okay? Then we're going to compare that to, if we put that into our calculator, so if we just do like our alpha y equals enter, and over 2.5, okay, that's going to give us 0.4, right, which is going to be equal to 2 over 5. Okay, so then if we're going to compare the medium to medium, right, medium would be 2 over 5. So medium over medium, if we do 2 over 5, that's the same thing, right? Both of those are 2 over 5. So now we need to compare the large over large. So large over large, we're going to say is 2.5 over 6, right? So let's see, 2.5 over 6. So let's go and put that into our calculator. Alpha y equals enter, or into our decimals. 2.5, we put that over 6. That's going to be approximately 0.416. So those are not similar because not proportional, right? So we have to check all three. So we see this one was good, right? That was good, but that one was wrong, okay? So if they're all the same, then we're good. All right, so that's on the level 1. All right, level 2. Okay, so use the proportions to find the value of x that proves similarity. Okay, so what do we know? We need to use proportions, right? So we know the proportions means something like this over that, right? So if those are the proportions, let's go ahead and fill it out. Well, we know this one will go on this right side, right? We need to use something with x. So we're going to say x plus 7, right? Now, what corresponds with this one? If we look at it, it kind of like flipped over, right? So this side right over here corresponds with that, right? 3 does. Now we need to use something else, one of the other ones. So let's use, I could use 8, but what corresponds with 8? Is it 5 or this? 8 corresponds actually with this one. Now I'm already using x, so I don't want to use that. So let me use these two. So I'm going to put, this is weird, 20 over 3. I'm just going to put that whole fraction right there, right? And then what would match up over here? The match up over there would be the 5, right? So I know that looks weird, but that's all we need to do. So now let's cross multiply, right? That times that equals that times that. So I always like working with my x's first. So if we did the 5 times x plus 7, let's write that down. 5 times x plus 7, right? Equals this times this. So I can say 3 times 20 over 3. Okay? So I know that looks weird, but let's do the math. You got this. Okay, so first off, let's distribute 5 times x and then 5 times 7. What does that give us? 5 times x is 5x. 5 times 7 is positive 35. Now, if we put this into our calculator, 3 times 20 over 3. If you put that in the calculator, the 3's would cancel, and you'd be left with 20. Okay, so now, wow, that looks a lot easier now, right? So keep going. What was the next step? That's right, we're going to subtract 35 first because we know we're going to divide at the end. All right, so we got 5x, bring that down, equals negative 15. All right, so if we divide by 5, x is negative 3. Okay, so that's what we do. Is just going to set up a proportion. So if we have something weird like that, which we probably will, this is a level 2, all we got to do is cross multiply, follow the same procedures. All right. So let's keep it moving. All right, let's look at a scale level 3. Okay, so level 3, we need to verify that triangle RST is similar, right? Similar to XYZ. So find the scale factor. All right, well, what's the scale factor? We need to have the correct side over the correct side. So let's set that up. RST, right? RST, and XYZ. XYZ. And we know it's the same way because R has to be the first one on each, S has to be the S and Y, and then T and Z, right? So RS is 12, ST is 15, and TR is 24. So RS is 12, ST is 15, TR is 24. XY is 28, YZ is 35, and ZX is 56. Okay, so if it is, then, so if similar, all sides must be proportional. Right? So let's check that. So we would say 12 over 28, right? So 12 over 28, if we reduce that, that would be equal to 3/7. Okay? So then we would try, right? We'd say 12 over 28, right? Then we would also try what? 24 over 56. So 24 over 56, okay, that also reduces into 3/7. Okay, so let's try that last one. We would try what? We would also try 15 over 35, right? So 15 over 35, well, that reduces into 3/7. Okay, so if that's 3/7, that's 3/7, that's 3/7, then yes, they are by SSS. So verified by SSS because they are proportional. All right, let's keep it moving. That's a level 2 question. Okay, so it says find the perimeter of this triangle. Okay, so level 3 perimeter, we know we're going to add all the sides. Okay, so if we're going to add all the sides, we need to find of QPR. So that's this one right over here, OPR, right? So we know that we're talking about this one right over here. Okay, that's what we need to find the perimeter of. Okay, so to know that, we need to figure out what x is, right? So we got to do a proportion, right? So we know we can set up a proportion to do that. So if we know we want to figure out x plus 2, right? So we need to use that. So which one does that correspond to? Well, if this is the right angle, right? That means This is our hypotenuse on each, right? Okay, and then this is the shorter leg. That's the longer leg. That's the shorter leg, right? That's the shorter leg. That's the longer leg. So let's coordinate. So the shorter one over here would coordinate with 3 right over there, right? Okay. So then next, what would we do over here? We could actually do either one over here, right? Whichever one we could match up with. So over here we have x plus 1. Well, I already have an x over here, so let's not use that. Let's use the 4, right? So I'm going to say the 4 over there. What would correspond with the 4? Okay, yes, that would be the 8 there, right? So now that we have that set up, it looks weird, but let's just cross multiply, right? That times that equals that times that, right? So I like working with my x first. So 4 times x plus 2. Let's write that down. 4 times x plus 2, right? Equals 3 times 8, right? Okay, so now 4 times x plus 2. That's going to be 4x plus 8 equals 24. Now it may look very easy for you, right? So we got 4x equals 16, right? And then we're just going to divide by 4. Last step, x equals 4. Okay, so if x equals 4, though, to find the perimeter, we need to add all the sides. So we have 3 different sides, right? So we have the perimeter is going to be equal to 8, right? Plus 10 plus x plus 2, right? And instead of the x, we're going to put 4, right? So 4 plus 2 plus 10 plus 8, right? So that's going to equal 8 plus 10 is 18 plus the 4 is 22 plus the 2 gives you 24. So the perimeter is equal to 24. All right, let's keep it moving. Next, we talked about on our last day, okay, 8.4, we talked about midpoint and triangle proportionality. Okay, so if this is the middle of a side of a triangle, and this is the middle of this side, and we know it's the middle because we have the same amount on each side, right? If that's the same on that side, that has to be the middle. If those are both the middle, then these have to be parallel. Okay, if they are, okay, a mid-segment connects the midpoint. So this is called a mid-segment. And the mid-segment is parallel, and it has the ratio of being twice as long as the short, right? So if the short, which is DE, is equal to the long divided by 2, right? Or the long is long is equal to 2 times the short. Okay, so let's keep that in mind on these mid segments. So that's what we do on mid segments, and proportionality is on the sides, right? So if we see like this triangle right over here, okay, if they are, the side parts are going to be proportional if these are parallel, right? If these are parallel, it makes these proportional to this. So we just set it up just like that, right? That over that on one side, that over that on the other, and we cross multiply, right? That over that on one side, that over that over the other, and cross multiply. Okay, so that's all we do on proportionality. Okay, and then when we see something like this, okay, we're just going to think the same thing. These would just make a triangle, so we just do the same thing. We'd say 8 over 24, right, equals x over 26, and then we would cross multiply. So let's get to some practice. So this says solve these problems. All right. So imagine we're trying to find x. Well, if this is the midpoint, if this is 9, then this has to be 9 as well. Okay, simple as that. On this one, check this out. This one we can imagine it's like a triangle, right? So we have these right over here. And this, if I'm trying to find that as far as x goes, I would just set up my proportions, right? So I could say 15 over 18 right here, right? Because that would be this side. And then I would compare that to this side over here, right? So I would say 16 matches up with the 15 and then x. Okay, then I would just cross multiply, right? Just like that. So if we did the x first, x times 15 would give you 15x. Okay, and then 18 times the 16, 18 times the 16 is going to give us 288. Okay, then we just know we're just going to divide by 15. Okay, so if you just push that divide 15, you're going to get 19.2. Okay, so that's all we have to do on that is just set up the proportionality. Okay, so keeping that in mind, now let's look at the level 2 question. So this one looks quite difficult, but I know you can get this. So what are these? These are mid-segments. So if we know the mid-segments, okay, then we know if this is DE, DE is equal to 7x is equal to AB divided by 2, right? So the short is equal to the long divided by 2, right? So if we know that the short one is equal to this longer one divided by 2, let's set it up that way. So we said 4x minus 3 is equal to 7x minus 1 divided by 2. Okay, so that looks quite gross, right? So we are going to set it up as far as a fraction goes and just cross multiply, right? I'm going to say that times that equals that times that. So I like to work with the 1 first. 1 times 7x minus 1 is still going to be 7x minus 1 equals 2 times 4x minus 3, right? That's what that says. So now let's just do the math. So if I did that, 2 times 4x gives me 8x. 2 times negative 3 gives me negative 6, right? Okay, so now that may look easier for you, right? Let's get our variables together. So I can move like this variable over here, or I can move the numbers over here. But let me just move the 7 over there. Either way, right? So I'm going to subtract 7x, subtract 7x. If I do that, the x's go away. It's going to bring down the negative 1. 8x minus 7x is just 1x minus 6, right? Now I already have the x's over here, so I don't want to move this over here. I want to move this over here by adding the opposites. The opposite of negative 6 is plus 6. Add 6, add 6. So 1x equals 5. So x equals 5. X equals 5. Okay, next, let's take a look at this one. Okay, so this one is talking about proportionality. Okay, proportionality on this one because we're talking about the sides. Okay, so mid segments are this one right over here. Okay, and then these are the sides. Okay, so when we're talking about the sides, we're just going to set it up. 30 over x plus 7 equals 25 over 15. Right, now let's just do our cross multiplication, right? So that times that equals that times that. So 25 times x plus 7 equals 30 times 15. Okay, so 25 times the x gives us 25x. Okay, 25 times 7 gives us 175. Equals 30 times 15 is 450. Okay, so then what are we going to do? We are going to subtract 175, subtract 175, cancels out. 25x equals, okay, if we put that in our calculator, 450 minus the 175, that's going to give us 275. All right, then what's our last step? We're just going to divide. That's right, divide both sides by 25. So that gives us x equals, if we did 275 divided by 25, that's going to give us 11. Okay, so that's our answer on that one is x equals 11. All right, so we're almost done. Actually, that is it.